Hello, this is Mr. Keaton here to talk to you about properties of chords, section 10.3 in geometry. Our first property here says arcs, if arc AB is congruent to CD, if and only if the segment AB is congruent to CD. So if the arcs are congruent, the segments are congruent, vice versa. If the segments are congruent, the arcs subtended are also congruent. So over here we have AB, segment AB, is congruent to CD, and that says that right there. Since that's true, this arc will be congruent to that arc. And since this one's 108, the measure of arc CD will also be 108 degrees. Pretty straightforward. Going on to the next one, we have CY, segment CY, bisects XYZ. So it's splitting this in half, which means these two pieces are congruent. Makes sense? That means measure of arc XY will be congruent to measure of arc YZ. A couple more properties here. If one chord is perpendicular to another chord, then the chord is the diameter. Since it's perpendicular right here and it's bisecting it, that means that is the diameter. So we can label that D. And the next one says if it is the diameter, if this is the diameter of a circle is perpendicular to a chord, if the diameter is perpendicular to a chord, then the diameter bisects the chord and the arc, which means that piece will be equal to that, and this arc will be equal to that arc. Properties of chords. So let's look at this example problem. This looks kind of confusing, this drawing here. It says three props are placed on a stage at points P, Q, and R. P, Q, and R. As shown, describe how to find the location of a table so it is the same distance from each prop. If it's going to be the same distance, it's going to have to be in the center, isn't it? So if we can figure out how to do a perpendicular one that's bisecting a chord, that will make this the diameter, won't it? That'll become the diameter there. That's from this property over here. So we have a diameter, and we have another one where it's bisecting this other segment here. We know where it's bisecting, so all we'd have to do is construct a perpendicular line through that bisector. And if that's perpendicular there, that is also a diameter. And since it's a diameter, they both go through the center, and now we have the point that is equidistant to all three props. By constructing the diameters on all these, on two of these perpendicular bisectors, we get the center, which is equidistance from the three props. Going on, next theorem says in the same circle, or in congruent circles once again have the same radius. Two chords are congruent if and only if they are equidistant from the center. So if this distance here is the same, then the chords are the same, or at least are congruent. So let's look down here in this example number 2. Use the diagram of circle C to find the lengths of BF. Oh, we've got a diameter, and we've got that it's perpendicular to another chord, thus it is bisecting it, and this BF must be 10. So segment BF is equal to 10. Next, example 4. In the diagram of circle P, PV is equal to PW. That's this right here. It's equal to that. That tells me from the theorem up here that this will be congruent to that, won't it? Because it's the distance to those is the same, and it has to be at a right angle for the distance to be the same. So since this is 2x plus 6, and this is 3x minus 1, I can say 2x plus 6 equals 3x minus 1, and now we can subtract 2x from both sides. Getting 6 is equal to x minus 1, add 1,